Alright, so what we're looking at today is that we're going to be looking at the mathematics of sharing. And the motto of this is sharing is caring. And so we're going to try to be calm, cool, because again, sharing is caring. And that's the motto of this one. Sharing is caring. Pretty important. Now, first things first, we've got a couple things to clear up. Now, players, again, are the people that are in this fair division game that we are messing with. Okay, we're dividing things up. Now, the first thing we have to assume is that everybody's got a value system. There are certain things that I value. I give a dollar amount. I give something of significance to other things more than something else. Okay, I could say chocolate is better than strawberry, which obviously is true because chocolate's just great. Now, JoJo over in the corner might say, no, Greta. No. We all know strawberry is better than chocolate. And I'll go, JoJo, I will get in fisticuffs with you if you want to fight over this. But I'm telling you that chocolate is better than strawberries. And then we get in fisticuffs and everything. So, anyway, but that leads us to our next point, okay? Even though everything's got value, we've got to be rational people, okay? We can't be having fisticuffs over something stupid, or we can't be shoving forks into toasters thinking, everything's going to be okay. We got to be rational. We got to be smart, okay? Everybody's going to do what they think is best for them. They're not going to just go out there and be like, in those war movies where somebody's like, just runs out there and starts shooting. Yeah, nobody's going to do that because that's not smart. We got to be rational here. It's math, logic. Now, the other thing that we have to do here is everybody's going to participate. Everybody will cooperate in this. We're not going to have somebody in the corner going, I don't want to do this because it's lame. No. Those are the people that are bringing down this world, and we got to stop that. Everybody's got to work together and be calm and everything. Okay? So cooperation is key to help us with this. Now, the next thing, even though you might know somebody for years and years and know everything about them, even about that one thing they did that one weekend that you won't let them go because it's hilarious and everything, everybody still has their privacy. Nobody here is Professor X. Nobody here can read your minds, okay? You have your privacy. What you think, what you value something over something else is for you and only you. Nobody else knows, okay? So people can adjust their playing of this fair division game based on what they know of you. Okay, everybody's got these privacies. And the last thing is the booty. Okay, what we're all trying to do here is get the booty. We all want the biggest portion of the booty, and we want the booty. Okay, and of course the booty I'm talking about here is the prize, whatever it is that we're dividing up. Okay, the money, the land, the cake, the pizza, the whatever it is. Okay, that's the booty. That's what they're going to be calling the booty, is whatever it is. So, okay, now that we've got some of this stuff out of the way, now, fair division games, there's two different types, and there's a mix of these two. So the first one is continuous. So let's say you have a booty that's like land or a pie. These are continuous fair division games, is what you would use for these. And the reason for that is because something that is continuous in this case, in these fair division games, can be divided up an infinite number of times. We can keep cutting this cake up over and over and over and over and over again, and over and over and over again, and this land, we can keep dividing it up continuously, non-stop. Okay, that's why it's continuous. So if the booty is continuous, that means we can divide it up an infinite number of times. Now the other one is discrete, just like the title of this class. A booty that is discrete, okay, is something that can't be divided up. It's got to stay as a whole. A house, okay? People, okay? These are things that can't be divided up. You can't give somebody half a person. They've got to have the whole person or the whole house. Okay, you either get it or you don't. And that's what discrete is. It's something that cannot be divided up. You can think like a candy bar. We're usually going to take candy bars as whole items, okay? And so that's what discrete is. Discrete is something that can't be cut into pieces. A continuous booty is cut into pieces. Now, let's get into these games. These games that we're going to be looking at are focused on continuous objects, so things that can be divided up over and over and over again. So let's say we've got these two guys that want to divide up this Twinkie, and we're going to call the red one, I don't know, Simmons, and the blue one Tucker. Now, when we divide these up, if there's only two people and it's a continuous object, we use the divider-chooser method. It's the easiest way to do it. You all have probably done this at least once in your life. One person cuts, the other one picks. That's the divider-chooser method. So the red one, Simmons, would cut, and then the blue one, Tucker, would pick. Okay, divider-chooser method with two people. Boom, done. Put it in the bank, lock it up. We've got this. Now, this is where it gets confusing. Now what if there's three people? What if somebody else comes along and wants to divide something up as well? Okay, this is where we're going to have to use these last two methods. So the lone divider method, just like its name, there's one divider. There's a lone divider. So they're going to be the first person. They're going to divide up this pizza. And they're going to divide it up into three parts, if there's three people. So 1, 2, 3. Okay, so we've got three pieces. After that, the two choosers, the other two people, are going to come along and say which ones they would not mind having. Which one is more or equal to their fair share. And they'll say, okay, I wouldn't mind having 1 or 3, and the other one says, I wouldn't mind having 3 or 2. Well, we'll say, okay, one person gets 1, the other person gets 3, and then the chooser sticks with 2, or the divider gets 2. Okay, and so the lone divider method, one person divides it all up, the other two choose, and the divider gets the leftovers. Pretty simple, right? Okay. Now, the other one, the last one, for this set of continuous, is the lone chooser method. Just like its name, there's one chooser. There's a lone chooser. So if there's 3, we're saying there's 3 people. The other 2 people are going to do a divide and choose to figure out which one they're going to want. So let's say we've got this cake, and they're going to go, okay, we're going to divide this up. I cut it right here, like that. Oh, let's finish this cut. Cut it all the way across. So they've cut it all the way across. Now the other person's going, I'm going to choose the top one because that one looks cooler because it's got the little thing, and the other one doesn't have has the point, and I don't like the point. And so the other person goes, okay, now that we've divided it or cut it into 2, and then the 2 people have chosen, what's going to happen is that each person that chose is going to divide each part into 3 parts. Okay, the number of people there are. So the top person likes the corners but doesn't really like the middle as much, so they're going to cut around like that, and now they've created 3 parts. 1, 2, 3. Okay, so now they've got their 3 pieces. Now the bottom person says, you know what, I could care less. Any of these work for me, so they just cut and cut. Okay, and now they have their 1, 2, and 3. Now that they've divided it up into 3 parts, what's going to happen is that the chooser, the lone chooser, comes out of his little hole where he's been hiding and has decided to go, I'm going to claim my booty right now. And so he's going to go along and go, okay, I'm going to take this piece from green and this piece from blue. And see, the lone chooser takes 1 piece from each person that has divided their sections up. The lone chooser will take 1 from each person. Okay? And everybody will get a fair share. Mathematically, everybody's got at least 33.333333% of the overall object. So these are the 3 sharing methods that we've gone over. The fair division games we'll go over now. We'll go over the last 3 a little bit later. And so hopefully you realize this, that sharing is caring, and we can do that mathematically because math is awesome. And everybody knows it. And you too. Yes, you do.